Just throw them in there. You're good. So, day 1-9 is what we're doing. We are talking about finding regression lines, where lines are best fit in a way. It doesn't necessarily have to be a line. It could be quadratic. It could be cubic. It could be a quartic. That's as far as we go, but it could go higher as well. A question for you is, how many points does it take to make a line? 2. Does anybody know why it takes 2 points to make a line? It's not the distance, it's going through 2 points, but the reason is, well, that is correct, is if you think this has an equation, mx plus b, right? How many variables are there that aren't y and x? How many equations do you have to have if you have 2 unknowns? 2. So for example, let's just imagine that this point wasn't here right now. Okay? Using these 2 points, I can write an equation by saying 30 equals, notice x is 8, 8m plus b. Right? This one could say 45 equals 10m plus b. Notice I just plugged in x and y for the points that were given to me. Does that make sense what I did? I plugged this 8 in for x, this 30 in for y, and that's 10 and b. This 10 in for x, this 45 in for y. We've got another equation. Notice if I have 2 equations with 2 unknowns, I am able to then solve for the unknown. How many of you guys remember doing matrices? Every time I hear matrices of your guys' age group, you're like, oh, it's horrible. So you're late. You're not. Not necessarily you're late. But once again, a lot of people didn't like them just because they were a little bit more difficult for them. One little step and you messed up, and you're right. But at the same time, I also believe that you guys weren't math mature enough for it. Meaning you guys had it in secondary 1, where your 8th and 9th graders were typically that if I was like doing it in a college type based class, would be in this class right now. The math 1050 class. So that's another reason why I think you guys just weren't quite math mature. Anyway, but it always takes 2 points because we have 2 unknowns. Okay? If I had 3 unknowns, like a quadratic, a, b, and c, because it's y equals a, m, a, x squared, well, I can't even talk to these. Not really. What's up, bud? Into the office. Do I? The M3 something. Okay. So notice A, B, C that are besides x's. Notice I'd have 3 points because I'd have 3 unknowns. Does that make sense? If I had 4 points, what could that give me? A cubic, because I'd have 4 unknowns, right? How about a quartic? It would have 5 unknowns, A, B, C, D, E, and so forth. So always, kind of a rule of thumb, is you need 1 more point than degree to find the equation that it goes through. But we're not going to do this by hand today. We're going to do this via calculator. Just calculator. Okay, who has any, anybody have a Casio that calculator? Oh, I don't like you. But you've been doing really well with it. Yeah. So, I'll let you figure that out on your own. Let Google be your friend. So today, though, we're going to go ahead and use these 3 points. Okay? And we're going to go ahead and plug them in and let our calculator write our equation for us instead of us having to do it. So here's what I'm going to do. So I'm going to pull up my calculator. Let me get this clear here. So here we go, everybody. So hit stat, hit stat. And you're going to edit. So just hit stat, edit, enter. Now for me, I have these stuff. Is there anybody put stuff in your information on L1, L2, and things like that? Please, Sage. I do. You can use it if you need to. Hit the clear button and not the delete button. So then if I hit, sorry, I have to do that. And then I hit over here, clear, enter. Notice it just does it. Don't hit delete because it'll delete your row. Say again, I'm sorry. Oh, you just deleted a row, or is it already been deleted? So for you, yeah. Yeah, so we can do two things. Not. Yeah. All right. I would pay attention, and then I'll just help you a lot. So what we're going to do, guys, is put those points in. Now, L1 is going to represent our X point. You're going to put it in L2. Okay? So go ahead and put it in. So it was 8, 10, and 11, I believe. Correct? Were those correct? 8, 10, and 11. Okay. In our L2, I'm going to put their designated. Sorry, it's not the greatest here. I tried to make it bigger, but this is the biggest it gets. Sorry. So who corresponds with 8? I believe it was 30. 45 and 65. All right. I'm going to quickly come back here because I didn't get to do what I really wanted to do. We're going to plot these points first. Maybe go by 5. Okay, so I'm going to hurry and quickly plot these points. So notice I was at 8:30. 10:45, 11:65. Are those exactly a linear equation? No. Just notice I'm going up on the first one, going up 1 for every 7. I'm going up 7.5 for every one I go over. On the other one, I'm going up 20 for every one I'm going over. So it's not a line because it's not exactly the same slope. You guys agree with that? Is it pretty linear though still? Did I almost get a pretty good line off of that? Yeah. Okay, and that's where this is going to come in. So we're going to go ahead and hit our graph here. We've already put our information in. Everybody hit second quit and go ahead and do that. That's your main screen. Make sure everybody's on the same spot. So hit second quit. And we're going to make sure our diagnostics are on, meaning we can have our correlation. So I'd like everybody to hit the second 0 button, which is our catalog. Now this is every function within your calculator. And I'm looking for diagnostic on. So instead of just scrolling down using this button, the down button, I'm going to go ahead and jump to the D, which is right by me. It's on the x to the -1. You know, it was the D button, and I just jumped all the way down to D. And I'm looking for the word diagnostic on. And you only have to do this once. When you do this once in your calculator, it will always be on. You don't have to do this every time. Okay. So I'm going to go ahead and hit enter. It goes back to our main screen. I'm going to hit enter again. It says done. And they completed that operation for me. Okay. Now once again, you do not have to do that every single time. We've done it. You're supposed to go down. See, enter, so it's done. All right. So what I want us to do is I want us to go ahead and find the equation. So what I'm looking for is the regression line. So I hit stat over to calculate. Now, if I had 3 points, I can either do a linear line, a linear regression, or quadratic. I'm going to go down to the linear. Now, for you, my lady, it doesn't pull up this screen. It just goes back to your main screen, right? I've been doing a lot of steps that you've been not doing following with. Yeah. Okay. So then I just hit enter through. If you have a TI-83 and you have L1 and L2, you can just hit enter. But if you don't, you're going to go ahead
What is this on?
diagnostic. You might not have to do that.
Oh, hang on.
Okay. So if you look at it, look, I have an equation because I have an A value and a B value, don't I? Okay. The other information is important. We'll talk about that in just a minute. What was the A value? Y equals 11.07x minus 3635-ish, whatever. That would be our equation of a line if we had it. If you'll notice, what's your R value? What did it say as our R value? 0.96. Now, this is our correlation. Our correlation says how close is this to being exactly a linear equation? If it's 1 or -1, if it's closer to those, 1 meaning it has a positive slope, -1 meaning it has a negative slope, okay? So if it's close to 1 or -1, that means your correlation is pretty close to a line. And we ended up with 0.96. That's pretty darn close, huh? Is it 1? No, 1 means it's exactly a line. Okay? But at the same time, it is a pretty close linear equation, isn't it? Is everybody there with me? Okay. So that's what that 0.96 represents. How close to being perfect is it? The closer it is to 1, it's better. The closer it gets to 0, it's not very good at all. Does that make sense to everybody? All right. So what's our other option? Because I have 3 points, I can do a quadratic as well. So I'm going to go here, and I'm going to do the same thing. I'm going to hit stat, calculate a quadratic regression, which in my case is number 5. And once again, I'm just going to hit enter all the way through. Remember, you need to hit L2. Okay. So, I have r squared equals 1. So what's our r value if r squared is equal to 1? 1. And it's perfect. And should a 3 points always give me a quadratic equation? Just a bit pop and clean it up. So our r value is 1. So it's perfect. And shouldn't something with 3 points always make a perfect quadratic? Yes. Why? How many points does it make to make the quadratic? 3. You have to have 3. Okay? Does that make sense to everybody? You're fine. Okay, so let's write our equation down. Once again, you guys have it. I have it right here as well, but we'll go ahead and write it. So this was our linear. This is our quadratic. Y equals 4.16, right? X squared minus 66.5. Okay, there's an equation. Now, here would be our linear line, basically. Noticing it might cross down here at -60, which is kind of what it's representing. Remember, I was going by 5. Hand sketch, so you can kind of get to understand why it might be a little off. Here's what a quadratic would look like. Okay, could it be that a little bit better? Might line up on that a lot nicer, huh? But what that just does is it allows me to go ahead and find, all right, this kind of has a determination of a quadratic. What if I wanted you guys to say, what is 12 comma something? I don't know what that is. 12 comma what would be on this graph then if I continue this information the way it was. Okay, anybody have an idea? Well, I can just plug 12 into that equation down there, couldn't I? Somebody really wants to do that. It's not very fun. So what we're going to do is we're going to store it into my y equals. Okay? And here's what we're going to do. Go to your y equals. Notice I have something in there. It's actually the one I was just on, but I'll show you guys how we all get to do this. I'm going to prove that out. Okay, everybody ready? Here's what you're going to do. You're going to hit the vars button. Over to y vars. Nope, excuse me, I apologize. The vars button. Down to number 5, which is statistics. Now I push over to the EQ, which is an equation. I want the reg equation. What that does is it just plugs that stuff into my y equals. Just puts whatever that regression line is, stores it into y1. So what? So here we go. Let's do it all over again. Here we go. Vars. I said y vars. So go back to vars. Statistics, which is number 5. Over to the EQ, which is an equation, which that says regulation equation. And it plugs it in for me. That's it. Okay, I'll work on yours in just a little bit later. Sometimes if I help everybody, it's a little bit harder. Just so I can make sure I get my time. Okay, now ladies and gentlemen, let's just graph it using Zoom 6. This is my regular window. Let's have a kid about that. Okay. That is up. So, ooh, what did it say? Oh, I have a problem. Hold on. I should just. Let me hang on, do it one more time. All right, here we go. Here's my graph. Nothing's up there. Why? It's outside our window. Well, think about it. My points are okay, but I do actually want to go over to 12 at least, right? Because that's what I was looking for. You guys agree with that? So I need to switch my window to there. And then notice, how high were those points? They were at least 65 was the high, right? So I probably want to go up to 100 or 200. Would you guys not agree? So I'm going to go down and make him at least a 15. And then I'm going to go to 200. And I'm going to go increments of 10. Then hit graph. Let's see if it pops up. So X scale, Y scale. Okay, there is our parabola given the 3 points that I was giving you. Okay? So what do I want to find? When X is 12, I wanted information, right? Anybody have an idea of how I can find X is 12? Trace is not the best tool. Value. Or I could do my table. See, look at table. Look at the 12th one down. It's table. My 12th one down to 3.62. That's the value, isn't it? But the one I did at the very beginning of my first period, I had to scroll up like 80 values, so that one sucked. Okay, so let me show you the nicest way, in my opinion, is once again, I'm going to hit the second, calculate, and these two ladies brought up the value. Now, the first thing when I do value, it has to be within my screen. Is 12 between my screen this time? Was it at first when I just had my standard window? So it would not find it for me because it was only at 10. But because now I went all the way to 15 or 20, I think that's what I did, it's now available to you. You guys agree with that? So I'm going to hit in 12. Hit enter, and I get 93.33, which is the same as the table, right? But what if they wanted you to find 12.5? Does the table work? No, hence why I like the value function better. Does that make sense? So once you hit second, calculate, and then do the value for that. Okay, how did we do? Not too shabby? So you guys are like, what the hell did I just do? Yeah, let's do another one though, okay? So, let's go ahead and do this. Okay. So I just basically wrote up, there's a little town in Alaska, which said, in the year 2004, it had a population of 457. In the year 2010, it had 1350. So obviously its population is growing. Is it growing linearly? I mean, I could do the slope on each increment, couldn't I? Right? And see if it's the same. Notice between 2000 and 2009, it grew 334 for every 2 years. So that's what? 334. Oh, 187 per year. But on 2009 to 2010, it grew only 71. So right there, I already know it's not linear, right? But I could find a linear regression to see how close it is, couldn't I? Okay, so let's go ahead and do that. Now, me personally, I don't want to write the year 2004 because that makes my numbers skewed. Does that make sense to everybody? Because then you're plugging 2004 in for X. What can I do to make it a little bit nicer? I could just say he's 4, 7, 9, and 10. Could I not? What's 0 represent then? 2000, right? Does that make sense to everybody? Okay, makes it a little bit nicer. So I'm going to go back to my calculator, and I'm going to hit stat edit again. Now, once again, we should all have information in our Y1 and L1 and L2 building. So once again, I'm going to push up into the L2, and I'm going to hit clear, enter. Don't hit delete, hit clear. Clear, enter. Okay. So if we look at our chart that you guys had, I had the year 4, so 2004, 2007, 2009, and 2010. Am I correct? You guys will help me. What is the amount for 2004? 400. For 2007? How much? 910. Then it was like 1244. And 13 what? Ooh, that was way too much for me. 1350. Okay. Here's my data. Now, because I have 4 points, who's going to have the regression correlation equal to 1? Remember my R value? Who's going to have the R value equal to 1? Is it linear? Could be. Quadratic? Could be, but the one that for sure is a cubic, because we have one more point than that degree, correct? Okay, so for sure, we already know r squared is going to equal 1 there. But is that always the best information? Well, let's go through and check. The linear, I'm just not going to waste our time just for time. I know it's not the best. Let's check out a quadratic, though. Okay, so how do we do so? I'm going to get out, so second quit. Okay, and I'm going to hit, once again, stack, calculate, number 5, the quadratic regression. Okay, my r squared value there says 0.995. That's my r squared. Do I want to care about my r squared, or do I care about my r value? The r value. So can somebody do the square root of 0.995 for me? I don't remember exactly what r squared is, but there is something more with statistics with that. I just haven't taken a statistics class in a long time. I'll be honest, I don't remember what that represents. Is that 0.97? Is that our 0.997? That's pretty good, isn't it? So that's almost a quadratic. Y equals, who's my a value again? -4. X squared. 203 positive, negative. Positive 203. Hey, did you give me a crystal ice or whatever? No. I don't know unless I try it. Minus. Did you give me a couple hot dogs? No, those silly ones. Hey, 2 dogs, me. After you're done, 295 straight up, right? With once again our r value being 0.997. Pretty darn close. Now, when I do the cubic, what do we automatically already know? Our r value is going to be what? 1. Automatically. It will always be 1. And the reason it will be 1 is because that's the stuff that will make a perfect equation. Does that make sense to you guys, what I'm trying to say by that? One more point than degree will always be perfect. I can find that equation using those points, because that's how many points it takes to make an equation. Does that make sense? Just like 2 points. If I give you 2 points, what will always come out? A linear equation, because I can always write it away from those 2 points. Does that make sense what I'm saying? I can always write a quadratic using 3, a cubic using 4, and so on. Okay? Does that make sense? But we're going to go ahead and do it now. Okay? We're going to go ahead and do the cubic. So I'm going to go second. No, I don't know why I'm doing second. So I don't need second. So just stack. Calculate a cubic. And once again, you guys are going to help me out here. Y equals negative. Plus 14 point something. I don't really care. But let's just talk about this in terms of our equation. Now we already see that our r value is 1. You guys all see that because r squared is 1. So that says it's perfect. Well, let's talk about the context of the problem. Okay? What would be more realistic in the year 2000? What would year 2000 represent in this equation? Which would be our y-intercept, right? So if I plug 0 into this equation on my quadratic, I get negative 295 meters, negative 295 meters. Probably not the best, but let's look at this one. In the year 2000, I have 1,421 in a small town. What makes more sense? The quadratic would, wouldn't it? Because not unless there's a plague or something, right? Where we're getting high, then we increase again, right? And in context of our problem, yeah, we could have a plague and then it goes on, right? Well, he's negative, so it should be like this. Oh, there's that other one. I'm struggling today, guys. I'm sorry. We can just graph it, I guess. Oh, my goodness. I'm gonna think, all right. So notice, we could have a high population that decreases and then start increasing again. It looks like we're gonna have a plague again. You know what I mean? Does that really look like a good representation of our population over time? Even though it's the best fit, right? Is that probably the best example of our population? Let's look at this one. Okay, so he's down here. This is its growth period. Does that look more something like what's probably going to happen? So even though my R was 1, in the context of the problem, my quadratic is probably the best I would use. Does that make sense? Everybody there with me? Understanding what I'm trying to talk about there? It's perfect, it is. Now, is it a perfect cubic? Yes, but once again, why is it a perfect cubic? Because there's 4 points. 4 points guarantees me a perfect cubic automatically. Yes. Like if I gave you 3, I'd have a perfect quadratic. If I gave you 5, I'd have a perfect quartic. If I gave you 100, I'd have a perfect x to the 99. Our R value. So right here, our R value was 1. So it's a perfect equation. This is a cubic equation with those 3 points. This is kind of forming those points to a quadratic. This is pretty close though, isn't it? Is it exactly 1? Is it pretty darn close? I mean, you almost couldn't almost get closer than that except for 1 itself, right? So, but what I'm saying is, yes, this one's perfect, but is this example really what I'm needing? No, because look at it. Look at the story. Hey, at 2,000, I'd have 1,400 points. I'm still decreasing, then all of a sudden I increase again. I'm going to get to a point, and I'm going to start decreasing. Usually towns, think about Saratoga and Eagle Mountain. We're still on a growth period, right? We're not going to really decrease in it. It's going to continue to grow. Right? Do you guys know, by the way, Eagle Mountain is the 3rd largest land size? So if we filled up, just like, I can't remember who's, I think West Valley's #1. The 3rd largest. Just curiosity, how about I ask you guys, who lives in Eagle Mountain that would be going to Cedar Valley? Not necessarily that if you live in Potter's go here, right? Silver Lake. Silver Lake, I think goes here. Just 3 of you? Everybody else lives in Saratoga? That is interesting. This is the first major Saratoga guy. Saratogian. Interesting. Okay, so do you guys get why I'm going to use this one instead? Now, on your test, would you be wrong if you use this one? Really, you wouldn't, because the R value is 1. But sometimes I want you to look deeper into it once you really explain. Okay. All right, so we're going to go ahead and find the year 2022. We're going to find the year 2022. So let me show you some cool tricks really quickly as we go. Notice my last regression line wasn't the quadratic, it was the cubic, correct? Let me show you how many, instead of having to go through that, watch. I'm going to hit second enter. What that does is it brings back my cubic. Is that what I wanted? Nope, which one did I want? Quadratic, so if I hit it again, there's my quadratic, and I can just hit enter. So if you hit second enter, what it does is it brings up previous information you've already used. Where's that useful? How many of you guys have ever put in the quadratic formula doing like -8 plus square root of 58 divided by 2? Something like that, right? Then what's the next equation? -8 minus the square root, right? Does that make sense? So if you just hit second enter again, it'll give you the exact same thing. You just look at the plus to the minus. Okay, here's our equation. Okay? So now I'm going to go y equals. I'm going to clear out whatever's in there. Can anybody guide me to find out how I store that quadratic regression in there? Good. Is that it, really? Luckily, we're almost done. Here, let me just finish. So we go to bars, statistics, which is number 5. Over to equation, and it's in there. Now, once again, I could graph it. It's not going to be perfect because my window's not large enough. How far do I at least need to go over? 22. This was only at 300. And notice, I probably want to go a little bit higher as well. Because remember, it was at 13, 15, right? It says right there for me. So we could probably go 2 grand. And I might go by increments of 100. And I'm going to go up here to 22. I at least need to go 30. Let's see what that graph looks like. See how that's just continued growth? That kind of looks like what that city might do, right? Does that make more sense? Okay, how would I find the 22? Remember, I hit second, calculate, value, 22. So that's 22,096. That seems realistic, doesn't it? Whereas the other one, if I put it in the cubic, guess how much the population is? Negative. So does that make sense? Hey guys, thanks, appreciate it.
What?